In less than 2 minutes, I'm going to take you from this problem statement to this solution. At point E, we're going to have a 300-pound force output. Knowing that information, you need to back solve to find what force P we put in to end up with that 300-pound output force. After reading the problem, but before we begin to solve for everything, we need to break up this simple machine into its constituent parts. You can see I've done so with part 1, 2, and 3. After breaking up the pieces of this simple machine, we're going to do a free body diagram for the blade of the shears. Starting with the angle, we are going to have to use the tangent function of the angle equal to opposite over adjacent. Solving for that gives us an angle of 40.23 degrees. With that done, we can do the sum of the moments about point C now. Here you can see that I've written negative 300, which should be positive, and positive FAB, which should be negative, given our customary sign notation. Solving for all that and doing some simple algebra, we end up with FAB being roughly equal to 373 pound force. Following that portion of the problem, we can move on to member BD, which is the lower handle of the shears. Given force AB and the angle it makes, we can split it into a vertical and horizontal component, which I show here. To solve for force P, we will take the sum of the moments on the body about point D, which is negative P times the horizontal distance from D. It is negative because the clockwise moment is negative. After doing that, we will subtract the moment that the x component of FAB causes, which is 373.27 cosine of the angle times the vertical distance. Then we will add the moment due to the y component of FAB, which is positive 373.27 sine of the angle times the horizontal distance. Doing some more simple algebra and solving gives us that the force P is about 31 pounds.